thought I was. Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another edition of Ask an OpenShift Admin. Today we're joined by many people to talk about the wonderful thing that is Multus and CNIs. So Andrew, you want to talk a little bit more about who we've brought on today and what we're doing here?
I would be happy to. I have to say that today's topic and the one from a couple of weeks ago with etcd, these are two of the most exciting things, the things that are most interesting to me from an OpenShift perspective, because they poke my buttons of being super technical and super critical of the things that are happening inside of the cluster. So I'm super excited, to just have everybody on today. So
Same.
Yeah, so before I get started, I want to just have a reminder that this is one of the office hours series of live streams that we have here on OpenShift.tv. So what that really means is that we are here to answer your questions. So for anybody who is watching at home, watching from the office, watching from the train, wherever you happen to be, feel free to ask us any questions that are on your mind at any point in time during the stream. And that's ideally, for us, because most of us are experts on the admin side, not on the development side. We'll entertain those developer questions, but we may not be able to help as easily.
If we can't help, we have a Discord channel, which I will drop in chat right now, and you can always ask there, and that'll give us an opportunity to go find the answer for you.
So that being said, we do have a topic for every one of our shows. And today I am, as I said, super excited to talk about CNI and SDN. And so CNI being container network interface, and I'm going to rely on our guests here to correct me and make sure that I am speaking correctly. So first of all, I would like to introduce and welcome Mark Curry, who is a consulting product manager with the Cloud Platforms Business Unit.
Thanks, Andrew. Yes. So my name is Mark Curry. I'm responsible for networking with OpenShift. And so today we're going to talk all about, hopefully answer any of your questions about OpenShift networking and CNIs and the plugins and Multus and how all of those tie together and why it is that it works that way. I'm joined by two of our top networking engineers, Doug and Tomo. If you guys could please introduce yourselves.
Hi, I'm Doug Smith, and I'm a member of the OpenShift networking team, and I work on a team that we call the OpenShift plumbing team, and we're interested in getting your workloads all plumbed up to the networks and the hardware to enable advanced networking use cases. And I'm joined by the guy who does all the real work, Tomo. Go ahead, Tomo.
Thank you. Hi guys. I'm Tomofumi Hayashi, and I'm pretty working on the Multus for 4 years or things with the Doug. And then I'm pretty appreciated that the answer your questions about the Multus, CNI, and then OpenShift as well. Thank you.
Yeah, one of the things I love about Red Hat is all of you are I think legitimately the smartest people I know, and yet you each keep passing the buck right to the next person. Mark is consulting product manager who hands it over and says I know nothing. It's completely up to Doug, who hands it over to Tomo and says I know nothing. It's completely up to Tomo. I love that factor or that aspect of Red Hat. So before we launch into that, for our audience, for the regular attendees, you know that I like to cover a couple of things that are top of mind, the things that have come up internally and externally regularly over the last week or sometimes last couple of weeks. So the first thing that I want to talk about is a bit of a selfless plug, shameless plug. That's the word I'm looking for.
There you go.
I'll get there eventually.
Early. You're on the East Coast, yeah.
Let's see. Let's share this window. So the first thing is just a reminder that every week we do publish the summary blog post from the previous week's or the current week, I guess is the way it works, show. So You see here we have our blog post from last week where we had Christian Hernandez on to talk about DNS and all the things going on inside of there. I'll go ahead and link that into the chat.
Thank you.
So those come out Friday morning. I'll have one this Friday that recaps everything that happened here. We'll share all of the links as well as the questions and stuff like that we discussed to help make that more discoverable for everybody. So the second thing I want to talk about is, so for those of you who are currently deployed or have currently deployed 4.6 clusters, and you noticed now it's been a little over a month, right, that 4.7 was released, and you still don't have a stable update channel or a release in the stable update. So yes, we know unfortunately, there have been a number of bugs that have been found. The most critical one, the biggest one that I'm aware of, is one that we've actually talked about before. Yeah. And that was, where when we update to 4.7 with vSphere clusters that are running VM hardware versions 14, 15, and 16, we begin to see some sporadic, right, inconsistent packet loss, which of course is a bad thing. So I know they're working diligently on that. I know that there's a ton of work, a ton of discussion happening internally. I see the emails flying constantly every day where they're trying to get those things fixed for everyone so that they can open the stable update channels. I will offer that if you're curious about that whole process and what it looks like and how it works and all of the efforts and all of the decisions that go into that, Rob Zumsky published this great blog post, 5 months ago now or so, that talks about this entire process and what goes into all of those things. And one of the things I thought was particularly interesting, and if we scroll down here all the way to, where is it? This chart. So this chart talks about the different channels that are in here. And I think last week I talked about how there's both a fast and a latest, and they're effectively the same. One of the things that I thought was interesting that Rob mentions in this post is we suggest that you have at least one of your clusters running the fast channel. So that way, if these types of things are going to affect you before you roll it out to all of your other stable clusters. So I thought that was an interesting, interesting thing. That also helps us, particularly if you have, the telemetry collection turned on, because that is how we help to determine when there are issues that might prevent us, that might, maybe we should wait to roll into stable with those particular releases. So great blog post, super timely information considering that it is a little bit longer period of time than we normally expect to go from a new Y release 4.7 and having those upgrades available in the stable channel. But do give it a read if you haven't seen it already. All right, so the second thing that I want to talk about here is just something that this is one of those that constantly comes up that I like to put out reminders for. So much like DHCP is required for IPI, one of the things that we get asked about a lot is compact clusters, 3-node clusters. Right? When we announced 3-node clusters, right? So you have just the 3 control plane nodes that are also marked as schedulable for regular workload. We used the term, right, for bare metal clusters. And what that really means is not necessarily it has to be installed on physical clusters or physical servers, but it can be deployed to any cluster that was deployed using the non-integrated or platform agnostic, aka bare metal UPI installation method. So this is sometimes a little bit confusing. One of the things that the docs team is working on, so you can see I'm in the 4.7 documentation, and I've selected the installing on any platform. This is the platform agnostic. And you can still see we still have this configuring a 3-node cluster option here. So it doesn't have to be bare metal. It doesn't have to be physical server specific. It can be virtual servers, so long as they meet the resource requirements that are installed with that non-integrated platform agnostic, basically platform equals none, as we see here, type of method. So just keep that in mind. And the last thing I have before we kick over to Mark is a question that got asked internally earlier this week, which was, can I convert an IPI or UPI cluster into bare metal? Right? Can I remove the cloud provider integration? And this question sprang from, I don't remember if it was a vSphere cluster or a Rev cluster, but they had deployed using, I think it was IPI. And basically they wanted to begin adding physical nodes. So it's a virtual cluster. I'm going to say it's vSphere IPI, virtual cluster. And they want to start adding physical nodes into that cluster. And you can't do that. You can't mix the platforms unless it's a non-integrated cluster. So the question was, well, can I just turn it into a non-integrated cluster? And unfortunately, the answer is no. And vice versa. You can't change a non-integrated cluster into a cloud provider cluster. Okay, that's enough of me rambling. So
we've already got a question, but I will save it for, I'm going to save it, but I'll just put it out there. Feel no obligation to answer this, team, and because we're going to kind of talk about it. One, real use cases of Multus. People want to see that. And second, what kind of CNIs have better performance for offloading, switching, filtering, so forth, so on. So let's try and cover that as we talk about our things here.
Yeah, we'll definitely cover that, Chris. And remind me if I forget, but I'm pretty sure I will remember those.
Yeah.
All right. So
thank you, Greg. Appreciate that. Or Oleg. Sorry, I can't read this morning either.
So enough of me rambling. I will hand over to you, Mark, and let you. I know you had a couple of things that you wanted to get started with. So.
Great. Thank you, Andrew and Chris. So to kind of kick the conversation off, I don't want to presume or assume too much about what people understand. So I want to talk about some fundamentals. And so the first thing I want to talk about is make sure that people have a clear understanding of what exactly a CNI or CNI plugin is and how it is they get used. So simply put, as you heard Andrew say earlier, the Kubernetes Container Network Interface, or CNI, it's really just a specification and a set of libraries for writing plugins to configure network interfaces in both Linux containers and pods. So when a Kubernetes pod is spun up, it needs networking information for its interface, and it gets that from the CNI plugin. So we have a default out-of-the-box CNI with OpenShift, as you might imagine. Our current default is based on OVS, and we call it OpenShift SDN. We have another next generation CNI plugin that GA'd at OpenShift 4.6 and that is targeting to become our new default at 4.9. That network plugin is Open Virtual Network, or OVN. So one of the first things I want you to get out of that information is that our own networking for OpenShift is itself a plugin, which implies the possibility of swapping it out for another plugin. So to that end, we also support a special CNI plugin named Courier Kubernetes. We worked with our OpenStack team, and so for those customers that are running OpenShift on OpenStack and prefer to avoid the double encapsulation that happens when you stack one overlay network on top of another, OpenShift on top of OpenStacks, Courier, kind of distilled down to the simplest explanation, is really just a way to collapse the two networking stacks down into one, that being OpenStack's Neutron networking plugin, whatever that might happen to be, so that when a pod is spun up, it reaches down to OpenStack, gets networking information, and assigns it appropriately. So in addition to those that we fully support within OpenShift, there are other primary networking plugins that we also work with. So through the partnerships that we've developed, we fully support several of these, and each has their own market differentiators. And sometimes they fill a gap in our own default capabilities that might solve a specific critical problem for a customer that maybe we otherwise either could not solve or just simply couldn't solve in a timely manner. So each one of those third-party CNIs, we don't just say, yeah, have at it, swap it out and support it. Each one of those has to go through a pretty rigorous certification process. The goal of that certification process is, there's sort of a predetermination of the lines of support between the two organizations, Red Hat and whomever that vendor is. Maybe it's Cisco, Juniper, Tigera, whomever. And so this way, the customer can just simply call Red Hat. Both organizations get woken up to whatever problem or issue they have. Mm-hmm. And then we've already predetermined whose responsibility that particular problem is. And then we get to work on it without the customer worrying about having, who should I call, Red Hat or vendor X. So that's one big part about certification, is determining those lines in the sand of support. Also to ensure minimum Kubernetes and OpenShift networking requirements are met. I'll talk a little bit about that. Ensure the plugin runs workloads that customers expect to run OpenShift. It should be, normal, quote unquote, Kubernetes networking. And also to prevent plugins from doing things that decrease security. The classic scenario, and I'm sure if you've been doing administration for a while, you've seen this. You visit a page that says, here's how to do this in OpenShift or Red Hat in general. And step number one is disable SE Linux, right? So we want to avoid that. Let's not do that.
Please don't make Pan Walsh cry.
So
Yeah.
so these are some of the goals of why it is we force certification on the things that we support. So what is the certification process for these vendors? They have to, first of all, make sure that all the containers that make up their solution are themselves certified, right? We don't want somebody just to create a solution based on a container image they pulled from who knows where. We want to certify, have them create a Kubernetes operator, and we want that to be certified. The minimum functionality of that operator is it just simply must be able to manage the lifecycle of the CNI plugin. They can make the operator as advanced as they'd like. You can do things like add the ability to ensure the health of their particular plugin across upgrades of the plugin itself, or even OpenShift. Another part of the certification is they have to pass the same Kubernetes networking conformance tests that we ourselves pass every time we make changes to our OpenShift plugins to validate that SDN. Now, those tests, they don't cover specifics of many of the market differentiators of the third-party solution, but rather they just ensure to users that standard, quote unquote, Kubernetes networking is going to behave as they expect and nothing was broken.
And to be clear, when we say it's a certified, SDN plugin, and I just realized you keep saying CNI, and I often refer to it as an SDN. So maybe after you're done here, you should explain to me the difference. I think I said when we were staging this that I'm going to play the role of dumb guy, which is like the role I was born to do. So, but just to be clear with the certification, like we aren't testing and certifying and validating that third party's functionality, right? We trust that their SDN is going to do what they say it does. We just want to make sure that from a Kubernetes networking standpoint, it meets that minimum standard.
Correct. And thanks for pointing that out, Andrew. The clarification there is that the CNI plugin is that thing that plugs into that spot in Kubernetes that can be called to get networking information. All the advanced features of networking are handled by the SDN portion of it, or the controller portion of it. And so for example, OVN is really a controller that is used to manipulate OVS flows to do the things we want it to do. And the CNI plugin is the thing that assigns networking information to the interfaces of the pod.
So that's an interesting distinction, right? Of CNI is the Kubernetes standard of how a pod connects to the network, and then the network provider, the SDN, is the one that implements that CNI interface.
That's right.
Okay.
Yep, exactly. And what I'm talking about here, and we haven't gotten into secondary interfaces and secondary plugins, and I'll talk about those in a second. But let me just complete this this first conversation by saying, really, what I'm talking about here is the primary networking plugins that are part of OpenShift. And so I've highlighted our current default OpenShift SDN, our next generation that'll become our default at 4.9. It's currently G8, however, which is OVN, Courier Kubernetes, and then we have a bunch of third-party ones. So what are the third-party ones? In no specific order, we value all of our vendor third-party networking solutions. So in no particular order, there are ones from, I'll try to do this mentally alphabetically, but there is Calico from Tigera. So we have a great relationship with Tigera and support their plugin. Some of the key reasons why somebody might choose Calico is they demand maybe BGP. Maybe they like some of the advanced security features. So it was Tigera that really upstreamed some of the network policy features in the very beginning. And they have some proprietary add-ons to that some customers might appreciate. So those are a couple of big things why somebody might choose Calico. Another one, Cisco ACI. So Cisco ACI obviously is supported fully by Cisco, and it really is. I hear a lot from customers, hey, I've got ACI deployed throughout my data center. Maybe it makes sense for me to use Cisco ACI as the plugin, and maybe it does. Maybe because that Cisco ACI CNI plugin might interact with the rest of the ecosystem of ACI throughout the rest of their data center and provide some advantage. And that's really for the customer to determine. Another one that we support is VMware. So VMware has what they refer to, they actually have two plugins. The first plugin VMware has is something they refer to as the NSX Container Plugin, or NCP. More specifically, traditionally NSX has referred to more of the one that's associated with ESX hosts, whereas NSXT is the one that's been more associated with Kubernetes and the container plugin. But more generally, it's just called NCP nowadays. And we do have a certified solution with them. So of course, if you're deploying on top of a vSphere environment or ecosystem, there may be some benefit to your using that one. Now, one of the, so they have a second plugin. I can broadly classify that first one as being proprietary to VMware, and it's not open source. And it's designed specifically to work on vSphere platforms. The newer one, which they're actually just starting certification of today, is their Entrea CNI plugin. Entrea is an open source version of a plugin that is not limited to just vSphere infrastructure deployments. So they have just started the certification of that plugin, and I'm expecting that to complete sometime in the second quarter of this calendar year. And then we have others. So Juniper has their Contrail plugin, which we're actually working with them right now. That's also in progress to get certified. And I think I've remembered everybody. Apologies if I've forgotten someone, but those are the big ones that we're working with today.
Yeah, and again, we don't performance test each one of those. So I think one of the questions was, well, which one has the best performance? Well, we don't know, certainly for all the partners, because we don't test them for their performance or validate their performance claims or anything like that. And I'll also say, like, the same stance. I have the same stance with CNI and SDN that I do with CSI and storage provisioners, right? They're all my favorite children. Yes. And my favorite one is the one that works for you and meets all of your needs.
Right.
We really have no preference outside of that.
Yeah, that's absolutely true, Andrew. And I would like to add to that. So we do nowadays also require a validation with some of our layered products, like, for example, service mesh. So if a customer uses, let's say, Calico with OpenShift's service mesh, can we guarantee to the customer that that's going to behave properly? And so we've added additional layers to that certification to do additional validation that they're not going to break some of the basic features and functions.
I didn't know that. That's good to know.
OpenShift virtualization.
Yeah, I didn't know that. That's good to know. I should really, one of our topics should be the certification process, Chris. I think
that's a good point. Yeah. Certifying those things. Question though, is there any hardware networking that works with OpenShift and Kubernetes right now, or is all of it SDN?
Well,
I feel like all of it's become SDN-ish.
ACI is one of those hybrids where it is actually, there is hardware involved in some of the decision process of ACI, right? So you can actually, you can literally run Perl scripts on Cisco routers that affect the hardware networking and influence the the ACI ecosystem that's involved. So I think it's really limited to that extent.
So I'm just there's been a couple of tangentially related questions that I'm gonna address real quick. So
What should
one
that-
from Usame, any plan to add vSphere CSI driver on Operator Hub? So I don't believe that their CSI driver is an operator.
No.
So the first step would be for them to create an operator out of it that we can then certify and put onto Operator Hub. So that would be the first step. And then the other one, where did it go?
And actually, Andrew, you bring up a good question about Operator Hub, if I can interrupt you for a moment.
Go ahead.
Which
Yeah.
is, so CNI operators, you may sometimes, actually, I don't know what the current situation is, but I believe it's the operators actually show up on our Operator Hub. But as you might imagine, today it's actually, there maybe more for information purposes, because CNI plugins are actually done at install time.
Got it.
Yeah, that's another question that I had for you at some point down the line, which was, we see, or I see, I wouldn't say frequently, but it comes up of, can I change my SDN, right? Can I change
Right.
the CNI plugin that I'm using?
Or something happens and I need to change it, like I'm forced to change it, kind of deal. Yeah.
Yeah, and
Yeah.
I think that this is a good opportunity also to kind of go into Multus,
Yeah.
or segue that way.
Yeah, and actually, just before I do that, let me qualify my previous comment, which is you can change CNI plugins, but let me be careful in my description. So we do have a mechanism today that was actually created by the engineers who have joined me on this call, Tomu and Doug, which is the ability to flip from one primary CNI plugin to another using Multus, and I'll explain Multus in a moment. But also, when it comes to secondary plugins, you can add them along the way. They would show up in any newly created pods from that point onward. And maybe they can address some of the details of that in more details later. But before we get to that, let me jump into Multus to kind of get that conversation going. So back in OpenShift 3, the telecommunications industry was really the catalyst for this. But it's definitely not just telco. It really was anybody who was doing any kind of network function virtualization, or NFV. When they started to transform their virtual network functions, or VNFs, to cloud native container-based network functions, or CNF, a very early gap that was identified was the inability to have more than one network interface on a Kubernetes pod. So the primary functional gaps then were people wanted to have these additional interfaces for purposes of network segregation, for both functional purposes like performance and non-functional purposes like security, but also the ability to do things like link aggregation and bonding for network interface redundancy. So to solve this problem, Red Hat's OpenShift SDN engineering and Doug and Tomu were big leaders in that, and NFV partner engineering teams. Also Dan Williams, Fungpan, these guys were big players in this. They formed a networking plumbing group, which you heard Doug describe earlier, that he's responsible still for the networking plumbing team within Red Hat. But they formed a network plumbing working group as part of the Kubernetes network SIG. This was done during KubeCon 2017 to address some of these lower level networking issues in Kubernetes. So it was chaired by Red Hat, but it was broadly attended with many representatives across the industry. I think we had somewhere upwards of about 17 different members that were all contributing input, somewhere along that lines. All with the common goal of achieving consensus on a de facto standard for implementing multiple network attachments in an out-of-tree solution. So there were a number of use cases that we gathered, and a standard specification was proposed. And what we collectively agreed to build, and what we did was we built a reference implementation for the solution using an upstream project initiated by Intel named Multus. So Multus CNI is a meta plugin for Kubernetes CNI, which enables the ability to create multiple network interfaces per pod and assign a CNI plugin to each one of those that have been created. And so fundamentally, there's a static CNI configuration that's going to point to Multus, And then every subsequent CNI plugin, as called by Multus, would get its configuration defined in a custom resource definition object. I like to imagine Multus like a power strip. So Multus is the power strip that converts a single plugin point, that static CNI plugin point of Kubernetes, to multiple plugin points. So we can add additional interfaces defined by additional CNI plugins. In our first release of OpenShift 4, we built Multus into OpenShift as a default meta plugin, whether you were using secondary plugins or not. So the option is always there. If you're not using additional ones, fine. It's just basically a pass-through. If you do want to use additional network plugins, then Multus, you don't have to do anything other than define the CRD and plug it in.
So a couple of questions there. So you use the terms primary CNI and secondary CNI plugins, and I would like to ask, what's the difference between those? And then my follow-on is, I've also heard of CNI, and sometimes in reference to Multus, being referred to as a pipeline. Like it pipelines those plugins together. And usually I hear this from the CNV or the OpenShift virtualization team, because they have their CNV bridge and their CNV tuning plugins, and they feed, my understanding is they feed from one to the next. So if you don't mind.
Yeah, on the second one, I may refer to the engineering folks on this call to talk more about how that works functionally, but there is an ordering to which the CRDs are parsed and the configuration is done. That may be more what they're referring to by pipeline, but maybe Doug and or Tomo can jump in on that one. But to your first question about the types of CNI plugins, there are broadly two different types. There are what I call the primary CNI plugins, and then what we loosely call secondary plugins. So, so you heard that the primary plugins; those are the ones that basically define the primary interface on every pod in the cluster, and Kubernetes itself doesn't fully understand, or it doesn't treat like a first-class citizen any of the additional interfaces. Kubernetes end-to-end is primarily focused on that primary interface. And so all control plane traffic, let's leave Multus out of the picture for a moment. All traffic, control plane, Kubernetes traffic, and data plane traffic traditionally would flow in and out of the ETH0 on every pod in the cluster. When you start to add secondary interfaces, Kubernetes remains on that ETH0, and you can define with those CRDs and additional plugins, you can define additional network interfaces that are separated from that. Now, the good thing about that is that this helped to solve some things that customers were asking for. Like in particular, I'll talk more about some of the different plugins, but let's choose one to discuss, and that is SRIOV. So SRIOV is a plugin that basically allows your traffic to bypass even the Linux kernel networking stack and go directly to the NIC. And so as long as you have a SRIOV capable NIC, you can communicate. That's the fastest possible way to communicate from the pod to the core network of the cluster. And so users were saying, look, I don't want that to be encumbered by all the other Kubernetes traffic for purposes of maybe performance, maybe for purposes of security or whatever. So what they said was one of the immediate and first use cases was to use that secondary plugin to separate some of that data plane traffic from the primary interface. You asked before for, what's a good use case for this for Multus. A really great use case is when customers are saying they want to use just exactly that functionality. We were one of the first in the industry to enable high performance multicast streaming. Because of this ability for us to plug in that secondary interface SRIOV CNI plugin. And so customers could redirect their traffic out there and achieve basically host line rate or their NIC line rate for their traffic leaving the pod and stepping onto the cluster network.
So we have a question, and Mark, I don't know if this is a question for you or Doug or Tomo.
Right.
But
Yeah.
so HC631 asks, you've talked about CRDs related to Multus. So which CRDs relate to Multus, and what do they configure? And if we want, I do have a cluster that I can walk through some things if you'll want to go that far, or if you just want to use words to paint a picture, that works too.
I'd like to invoke Doug and or Tomo to
Sure. Let me give a quick overview. Typically, when you're administrating OpenShift cluster, what you're going to look at is your networks object, and that's where you configure your networks as a whole. And also, it's probably a good place to kind of memorialize the configurations you have. So if you have parameters for OpenShift SDN, for OVN, you're probably going to have them there. And you can also configure your additional networks there in a field that I believe is called additional networks. That is then an abstraction from the custom resource that Multus used that's called a network attachment definition. And it's that particular custom resource. It's very simple. It's basically a field that's a blob of JSON that's a CNI configuration itself. So it allows you to say, this is the CNI configuration for this additional interface.
So I'm going to share a screen here real quick so that we can walk through a couple of things, and I'll ask you to perhaps explain what we're seeing. Uh-oh. I don't want to share.
What are we seeing?
I don't want to share the whole screen. Not that there's anything to see there. I just wanted to share the one window. So, because I understand ultra wides on because I have an ultra wide monitor on the stream, just don't work that well.
I mean, they work, but you just can't read them.
Yeah, it's hard to read. So I have here, I provisioned an Azure cluster this morning. It's running 4.7.2. So Doug, you were just saying that we want to look at the network CRD. So if I do an OC-get network, which is a global object, we see that we have the cluster. And if I do a -o YAML, we'll see the contents of that. And this should look kind of familiar because this is more or less the same stuff that you saw in your install config -yaml or .yaml when you were setting up the cluster. And that includes, you can see here it's OpenShift SDN. If I were to substitute that for OVN Kubernetes, if I were to configure additional networks and all of those things, all of that happens with this particular object, right?
Nice.
You got it. And what you would do is you would just be adding a line here under the spec that would be additional networks. And in the OpenShift docs, it details all the particular parameters and goodies that you can configure there. You also could potentially do an OC explain network attachment definition. Hey, there you go. Great. There you go. Yeah. Awesome. There's a net attachment. Perfect. Yeah. And kind of two things to point out here that are really important is the name, the metadata name, and you're going to use that. You're going to refer to that in pods as an annotation to say, hey, this is the additional network that I want, or one of many additional networks that I want. And then in the spec, the config, that's a CNI config, which are in JSON, and that's how you configure an individual CNI plugin. And some of those fields are static and required for everyone. So name, type, or plugins, CNI version, those are generally required. And then the rest is freeform, so it could be specific to the CNI plugin.
So Doug, let me add one comment in addition of that. So not only the name, also the namespace is important at that time. So if you creating the pod, so how do I say?
Yeah.
So the network attachment definition and the port should be in same namespace. So if you create the CNB BR1 at the default, and if you create the port for that in the another namespace, okay, let's see the Hoover. At that time, the Multus may causing an error. So please create a network attachment definition and the port YAML in the same namespace.
Got it.
Okay. Yeah, that makes sense. I think at one point the documentation said that they could share across namespaces, but when I tried that, I think I was told that was a bug in the docs. So
there are, so generally we they're required to be in the same namespace. However, the default namespace is special. You can refer to a network attachment definition in the default namespace from any namespace.
Oh, that's interesting. I didn't know that.
Wait, say that again?
And so say for example, you've got 100 namespaces,
right,
and you need 100 different network attachment definitions. So you could use it in 100 namespaces. We said, no, we got to have a way so you can share that in that particular case. So you'd create the network attachment definition in the default namespace, and then when you annotate it, you use a format with a namespace /name. So you would say default/foo, for example, and that would allow you to do it. So yeah, default is special. And so also keep that in mind for security considerations if you don't want it to be used across namespaces as well.
Yeah, very valid point. Yeah.
I assume that's either a permissions thing or just delete the default namespace and you can, fix.
Absolutely.
Okay, that's really interesting.
Yeah.
So it's funny because Chris and I chat about these shows, and I usually try to have subjects and things that I like to think I'm at least knowledgeable on, so that I can hold the conversation. And I feel like I have learned just a tremendous amount from you all already. So thank you.
Yes, exactly.
All right. So Chris, do we have any questions that have come in? I haven't been.
Once an additional network is configured and the network CRD, the net attached definition is already created, right?
Yeah, so our operator creates that for you.
Okay.
So yeah, that which is the cluster network operator that does that.
Cool.
Okay. So I have a question, and in particular, if we look at, and I think Mark, you refer to these as the secondary network plugins. If we were to look, for example, in the OpenShift GitHub, and I'm going to share my screen again. I think that's the right screen to share. It is. So if I go to like github.com/OpenShift, if I could type and talk, if I just do a very cursory, like type in CNI in the search field here, right? We get a bunch of CNI plugins. And I think these are what you're referring to as the secondary plugins, like this whereabouts. And, here's Multus, which is not a secondary, route override CNI, SRIOV, so on and so forth. So can you kind of describe what some of these are, maybe when I should or shouldn't use these?
Well, let me adjust it at a higher level, and then given the fact that Doug and Tomu are authors of some of these, I will I'll redirect the conversation to them pretty quickly. But the premise is that these secondary CNI plugins, these enable our customers to immediately take advantage of some benefit that's afforded by some other CNI plugin implementation. You didn't have to wait for this to show up in Kubernetes proper. This is something we could implement as a secondary CNI plugin faster. It may end up evolving into something that's a fundamental feature of Kubernetes, but this is something that today would be enabled as a secondary function on a secondary interface. So there's a number of different plugins that we support. Several of these actually came from the Kubernetes upstream reference CNI plugins. And we, of course, do the Red Hat thing, which is to downstream and then enterprise harden those particular plugins. And then there are other ones here that we created out of need. There was some functionality that was not there that our customers were asking us for. So, for example, there is, IPVLAN. And so this is really about assigning sub-interfaces their own unique IP address and they all share a common MAC address. An example would be something like AWS, which uses IPVLAN instead of VXLAN overlays for their VPC offerings. And so you would see lower latency and improved throughput with that. Another use case for something like IPVLAN are customers with pods that are in VMs that want to use the VM's MAC for egress traffic and not that of the host. So there's a number of use cases to each one of these. And at this point, I think what I'll do is I'll hand it to Doug and Tomo. Doug, there's another one you have in here that I know for sure that you were the one who created it, and that was the whereabouts. Maybe start with something like that and explain how that got started.
Yeah, absolutely. Whereabouts, it's a special kind of CNI plugin. So even as we were talking about what's the difference between an SDN and a CNI, there's actually a number of different kinds of CNI plugins. One of those is an IPAM CNI plugin. So it's like a specialized type of CNI plugin that works with other CNI plugins that provides it with IP address information. And in the case of whereabouts, we discovered that in some scenarios, users were having trouble getting IP addresses to all of their workloads across the cluster. So we had a lot of examples that used a host local IPAM CNI plugin, and that IP address information is stored locally to each host. So you'd go to assign the IP address on 2 hosts, and you get the same IP address, which is of course a disappointment because guess what? In the real world, everyone has a cluster that's bigger than one, and maybe in a dev environment, you just have the one host. So we realized, you know what? It's not always easy to get that across hosts. So what whereabouts does is assigns IP addresses to other CNI plugins and therefore interfaces to pods and Kubernetes using custom resources. So you just give it an IP address range, and it says, okay, I know how to figure out which IP addresses are allocated or not, and it assigns those for you. And one place where we've seen this to be particularly useful is in isolated SRIOV networks. So let's say you've got this, you've got a media streaming platform and you've got all your high performance video, audio going out this one interface, but what if you don't have DHCP access on that? Well, you don't necessarily need to go and then set up a DHCP server. You can just throw in a couple lines of config and say, hey, can I get an IP address from this range, please? And that's what whereabouts does.
Very cool. And so it's not like assigning IP addresses to pods that are connected to OpenShift SDN because it has its own mechanism to do it. It's rather if it's connected to some other, SDN, for lack of a better term, or some other network that is CNI controlled, and it needs to determine an IP address for that. So I'll pick on like OpenShift virtualization, right? You said, hey, I can create a second interface, a second network interface on my host, and it's connected to some network that doesn't have DHCP, but I can use whereabouts to manage IP assignment for that.
Yeah, absolutely. And it has a number of features like excluding ranges. So say, for example, you're trying to play nice with other existing infrastructure in your network, and you want to say like, hey, I know I have this /24, but we have these legacy 10 IP addresses that, I don't want to collide with those. So you can specify stuff like that.
Very cool. So I'm going to change directions ever so slightly. And I'm going to ask you guys what is a bit of a scary question. So I hope I'm not alarming you. And that is, what can go wrong? Like when we think about, and I know like SDNs, sure.
Nothing, Andrew. Absolutely nothing.
I was about to say, one of my previous professions was a network engineer, and it's like, ooh, all the possibilities.
Yeah. And I think it's one of those, like, a lot of times we think about, the SDN isn't able to instantiate itself, right? The nodes can't talk to each other. The VXLAN tunnels can't be created, whatever that happens to be. So are there common things? Let me narrow this down, right? Are there things that commonly go wrong? And do you have any suggestions for like troubleshooting or how to identify those?
Mark, do you mind if I take it away?
Please do.
Yeah.
All right, cool. So as you know, networking, I wish it was just as easy as plugging Ethernet or optical cable in and everything worked. That would be great. But in the meanwhile, a lot can go wrong. So let me talk about a few of the things that we've done to help mitigate that for you in OpenShift. The number one of which we have in terms of additional networks is we have an admission controller, so that when you go and create these custom resources, it does some cursory checks on those to make sure that things are formatted the right way, that kind of some simple mistakes, it can stop you and say, hey, can you double check this before I go and instantiate it? So that's one thing. Kind of the next thing that you might see happen is if you've made a mistake that our admission controller couldn't pick up on, Multus may pick up on it. And Tomo created a functionality for Multus that uses Kubernetes events. So if Multus finds a problem, it's going to create a Kubernetes event, and you're going to see those in a OC describe pod foo. And hopefully you see an event in there and it says, like, here's a common mistake that we see all the time is you go to use Mac VLAN CNI and you're like, hey, I want a Mac VLAN interface on this. And you need to specify a interface that exists on your host system. If you've specified the wrong interface name, when Multus goes and runs Mac VLAN CNI, Mac VLAN CNI is going to return to Multus and say, hey, didn't find eth_foo. And Multus will then create a Kubernetes event that's going to say, I couldn't create Mac VLAN because there's no interface on the host called eth_foo. So that's going to be one of the first places you're going to get your hints. And in terms of CNI, CNI is generally a one-shot, event-driven API. And your SDN itself may be doing things that are more complicated, has more of fault tolerance, has more of a state to it, whereas there's going to be CNI events. The ones you're the most concerned about as an administrator is on CNI add and CNI delete. So that's when your pod's created and when your pod's torn down. So if you go to create a new pod and it doesn't come up, if you're doing a watch on OC get pods and it's saying crash loop back off and all that, go ahead and describe it first. That's the first thing I would say to do, because something might have happened during a CNI add. If you don't have enough information there to figure out why the pod wasn't created properly, there's a few other places that you might want to look. One of which I would say is the kubelet logs. So the kubelet, libcni, cryo, there's like a kind of constellation here that all works together. A lot of those logs are going to be trapped in the kubelet. And the CNI API itself is all standard in, standard out. It's fairly basic, and that, so when you have an error, it's in standard error. And that standard error is going to be picked up by the kubelet itself. So you should be able to rip through those logs and figure out if you need a little bit more detail.
So we've got a statement and a question. And Waleed, I'll go ahead and ask your question just so that we can get verbally address it.
Right.
So statement from HC631. Trailing commas, which are normally accepted as functional JSON, don't get accepted in the network object if they aren't followed by another key value pair in the JSON, in the network object. So I think that was just a statement of, it seems like there might be some non-traditional parser behavior there.
I would love to have an upstream issue created for that, because that's actually news to me about the JSON spec. I honestly thought, and maybe it's from a CNI specific bias, but I didn't know that those trailing commas were okay. So certainly if you look for the container networking GitHub org upstream, that is probably a good place to start to file an issue. and that'd be cool to fix.
Awesome. And then Waleed asks, so we can change the primary CNI after install. So for example, move from OpenShift SDN to OVN Kubernetes. What happens to the pod and service configurations? Do they need to be restarted? Does the node need to be rebooted?
That is handled for you by the operator. And what I believe that the operator does is that it gracefully drains the nodes and reboots them when it needs to.
Okay. And I think that also answers one of the kind of very first questions we had, which was, can you replace the SDN, and substitute one for the other? And I think the answer to that is yes. Although, as Christian pointed out in the chat earlier, sometimes the options that you want to use, so for example, OVN Kubernetes with hybrid networking, have to be decided upon before the install happens. So
yeah, if I could address that one first, and then I'd like to pass this on to Doug to maybe talk a little bit more about how this works. We have our first real challenge in this space with moving from our current and legacy default of OpenShift SDN to OVN. So we need a way to get our new customers onto our next generation OVN networking, where all of our new development is going, without asking them to greenfield redeploy their clusters from scratch again. Mm-hmm. So we looked at a lot of different possibilities for the primary CNI plugin to go from one to another. And it turns out that Multus is a great tool to facilitate that move. And essentially, Doug, do you want to address some of the specifics on how that works?
Yeah, totally. And basically, in a nutshell, the gist is... Doug, sorry to interrupt you. I just want to let you know that we've only got about 2 minutes before, and we have a OpenShift Commons briefing right after this. So just to let you know. Cool. 20-second answer is essentially your pod has one interface. It's your primary pod-to-pod network traffic. What we do is we plumb another interface in with your alternative SDN, and then we switch the traffic over that way. That's essentially how it goes. Nice. Yeah, that's Multus seems like it was, I'm not sure if it was super smart forethought or accidental genius, but it seems like it solves a lot of problems.
Super smart forethought, Andrew.
Yeah,
come on.
Of course. That was what I was going with. So as I said, we do only have about a minute left now before we go over to OpenShift Commons briefing. So I want to take the opportunity to thank you, Mark. Thank you, Doug. Thank you, Tomo, for coming on today. This has been really phenomenal. Thank you so much for all of the information that you've shared with us. So I saw HC631, I saw you said you have another question. Please feel free to reach out to me or Chris. So andrew.sullivan@redhat.com or on social media, Practical Andrew at Twitter. You're welcome to reach out to us anytime. We'll make sure that the team here gets those questions and we can get good answers for you.
Absolutely.
Yeah, and so thank you again for everybody who is watching. Please keep an eye out Friday for the follow-up blog post that has all of the details and stuff that we shared inside of the session. Right. Thank you again, Mark, Doug, and Tomo, and have a great rest of your day, everyone.
Yeah, thank you very much, everyone.
Yeah, thank you. We'll see you here in a few minutes on OpenShift Commons, everybody. Thank you very much for tuning in.